We're looking at mile marker 4, practice 1, question 5. In question 5, you're asked to find the length of the arc AC. Couple things we need to think about. First of all, we know this is a minor arc, and we know that because AC, we're using a 2-letter notation. So when we use 2 letters, we're talking about a minor arc, this arc, as opposed to going all the way around the circle and getting this major arc. We would need a third point to name that major arc. We're told a couple of things here in the picture. We see this 9 floating above this. Well, this is a radius. So from this, I believe it's safe to assume that our radius is equal to 9, the radius of this circle. We also see 100 degrees here. So the central angle of this arc is 100 degrees. Now, that's not what the question's asking. It's not asking for the measure of the central angle of arc AC. It's asking for the length. That length is going to be a linear measurement. So if you kind of trace this arc, the length we're talking about is part of your circle. So it's part of your circumference. And the length of this arc is going to be proportional, the ratio of the length of the arc to the circumference of the circle is proportional to the ratio of the degrees in the central angle to the entire circle. So we could really solve this using a proportion. If we just kind of hold our thinking in an organized sort of way, I'm going to label and say that I'm going to compare my arc to the circumference of my circle. And I know I'm first going to make a comparison by degrees. So in degrees, my arc, its central angle is 100 degrees. And I know in a circle, there's 360 degrees in a circle. Then I also need to compare the circumference to the unknown, which is our arc length. Now, you might be wondering, well, where's the circumference? Well, we don't know. We got to find that. We know circumference is pi times diameter. So you've no doubt seen this equation, pi d for circumference. You've probably also seen 2 pi r. And all that means is that if we double our radius, we get a diameter. So I always like to use this top equation, and I just think if my radius is 9, I know a diameter is composed of 2 radii. So my diameter must be then 18, just 9 plus 9, or 9 times 2. So my circumference, and it's okay to leave this in pi notation. In fact, at the top of the mile marker, it says, when applicable, leave answers in terms of pi. So we're going to leave this in pi notation. So instead of multiplying 18 by pi, I'm just going to say my circumference is 18 pi. And what I want to find is my arc length. I'm going to let x represent that length. But you know what? Since we're doing this in pi notation, I'm going to say pi. I'm going to say x pi. By doing that, x is really just representing this number in front of pi, and I don't have to worry about multiplying by pi in my proportion. So now we're comparing, we said this is degrees, and this is going to be length here. So I hope you recall from this year, we've learned a lot about how to solve proportions. We solve them using cross multiplication. So we can cross multiply. We're going to multiply 100 times 18. We're going to just kind of leave pi out of it for right now. And then 360 times x. If we were to multiply both sides by pi, they would just cancel out because I could divide pi off of each side. So that's another reason that we can actually just leave pi alone while we do this. So 100 times 18, you might need a calculator for that, or you might just think 18 times 10 would be 180. So times 100 is 1,800. And then we're going to set that equal to 360 times x. Now, sometimes people do this in one step in their calculator, but we now have to divide both sides of this equation by 360. All right, so we want to go ahead and divide this by 360, and we're dividing 1800 by 360. And as I'm doing this, I realize I don't have my calculator handy.